So, most of you probably know Jean-Pierre by call sign and by his postings on the forum. Probably not met him in person, but I certainly had the pleasure of seeing him a few times over the last 6 months, and it's sort of great pleasure to be able to introduce him to the rest of you. And essentially, he's going to talk about. Let me check first. So 2 sessions rolled into one, probably running up to probably about an hour, just over an hour, which will talk about the Tutioune software, including how to spell it. Yes. We have this conversation every time. And then he's also going to talk about the hardware, the mini USB tuner board, which is mini Tutioune or something. Yes. Thank you, Jean-Pierre.
Tutioune, mini tune, people tune. Yes, the tune, like it is written, is very strange for you. But the first time I have written the software, I just call it Tutioune, T-U-N-E, like you. But in French, people said Tutioune. So to oblige French people to speak with the English French, I have written tune in phonetic, in French phonetic. So it's just tune, but written in phonetic for French people. That's all. So, and the first time for this project, I had to tune the part that can receive the frequency and to tune the part that can decode the transfer stream. So I had 2 tune. That's all. That comes from, this is just the story. So I started to develop this software in 2010, 2009, 2010, because when I started to play with DATV, I was searching what kind of tools can we use to receive intelligent tools and tools that can measure the signal to know when we receive or not, why we are receiving or not. And I found nothing. I was very astonished to see people using a set-top box. A set-top box, I have called them at this date stupid box. Because when you use a set-top box, you just see 2 information, quality, level, and quality. And where they are green, you already know that because you see the video. And you can compare one box to another. You have never the same level. So it's not a tool for me for ham radio. For ham radio, we like to have a rig with many squelch, noise blanker, and so on and so. So I cannot use just a set-top box. So I started to develop Tutioune. And we will see during this presentation some picture about Tutioune, mini-tune, for people that don't know this software. The first idea was to create a tool for measuring the signal. It's just something that happens, that I can receive also a video. But the first target for me was to measure, to be able to analyze a DVBS signal, because all equipment cost at very high price. So what can we do? We just a little PC card. At this date, I used a PCI card, tuner card that we can buy at 50 pounds about 50 pounds. So the last work was when we meet with Noel and many of guys from the BATC about the low symbol rate problem. Because when we are using a set-top box or any kind of receiver, you can receive, and sometimes you don't receive anymore. If you lower the symbol rate, the receiver cannot receive anymore. Some receiver cannot receive under 1,500 kilosymbol. So we put it away. And we have spent some years to search which STB was able to receive 1 megasymbol, down to 1 megasymbol, because the software or the firmware that is inside all set-top box stop at 1 megasymbol. But when you are using a PC, you can, by software, ask lower symbol rate. But you ask lower symbol rate, but sometimes it works, sometimes it doesn't work. And when we try to observe what kind of result we have, we know that for us, when we are thinking in the analog world, when we lower the bandwidth, we have a better RF performance, we have a better noise, carrier noise result, and it's go better and better. But when...
You can use the gun if you like.
Oh, but I don't see it. I am colorblind. Well, yeah, I'm sorry. No, yes, okay. What? You understand some colors, perhaps sometimes?
Some of the displays are
yes.
bright.
Yes. So, I suppose I have a receiver, a set-top box, that can receive down to 600 kilosymbol. At 600 kilosymbol, it stops to receive. If I go lower, I cannot receive anything. And when you have this kind of receiver, it don't receive, and suddenly doesn't receive at all. There is a little degradation of performance before the receiver cannot receive anymore. So my question was to know, yes, it was a question I have asked to myself 2 or 3 years ago. I wonder where can we go and continue to win, to gain in performance. So if I combine the two graphics, I have this kind of result. That means that for this receiver, when okay. Okay. When I go down to 800 kilosymbol, the performance is always better and better. And when I continue to lower the symbol rate, the performance goes better, but just a little. And when I arrive to 700 kilosymbol, I am losing in performance. So I just want to say that if you have a set-top box that can receive at 1 megasymbol and you try to make a contact, perhaps that at 1 megasymbol your set-top box has already some difficulties, and if you try at 1 megasymbol 0.3, you will have a better result. So this was the first solution, the first result I had, and the question was, is it possible to lower this dead-end value? Can we go further? Because when we look at all the documentation about the demodulator chip, we will see always that they are written from 1 megasymbol to 45 megasymbol, but never under 1 megasymbol. So the question was to understand where is the difficulty. What is the part of the demodulator that cannot work if we lower the symbol rate? For that, we must understand a little how works a demodulator. We must isolate this part and try to see if we can change some value and find how to fix this problem by exploring different parameters. And I have spent 3 months from October to December trying different parameters, having my friend Foxtrot 9 Zulu Golf that doing many tests on the air, on the real air, at some distance more than 200 kilometers. So if I just look at a DVB-S receiver, we have 3 parts. The first part is the zero tuner. This zero tuner has a preamplifier and will do the IQ extraction that will go to the DVB-S demodulator. So we are in the analog world. But when IQ signal go in the demodulator, there we will see that the 2 signals are immediately digitized. The demodulator will have to find the good frequency, because also we will see that we are never on the frequency. This is something special when we are playing USB, CW, and so on. We are able to be on the good frequency. When we are playing DATV, we are never on the frequency. And sometimes you are at 500 kilohertz of the frequency. It's very strange in our mind. I try to listen something. I look here to see something that is here. It's very strange. But it works like that. So, IQ go in the demodulator is digitized, and there is a little tool which is called that is called the derotator. We can see also for what reason we call it the derotator, that will search the real frequency, and after the demodulator will extract the transport stream, and the transport stream go to the demultiplexer, the MPEG-2 or H.264 decoder, and you have after the video card and audio card for the rendering process. One example, if you use a PCI tuner card like the Technotrain, you will have a half NIM tuner. There is only the zero tuner inside. IQ go to the demodulator, and the transport stream, we will see this line, go to the interface with the PCI BIOS. All components are voltage, the LNB, and infrared remote control. So, if we look at a little diagram, we have the zero tuner, IQ, the demodulator. The demodulator is set up by software using an I2C line. And we have an interface for the PCI bus, but it can be also for USB bus. If we look at quickly the mini tuner, we have seen it, this little mini tuner, just to see what is the diagram. The first difference is just we have a RF booster. I have seen that someone, perhaps you, have written an article with a comparison between the Technotrain card, the 1600, and some set-top box or professional. Yep. Yes?
Yep.
And you say the 1600 is the less sensible. Sensitive. Thank you. The less sensitive. Yes. And the reason is, I think, just because all set-top boxes have a NIM tuner. We will see what is NIM. And in the NIM, you have always RF booster. And there is no RF booster on the Technotrain card. So this RF booster gives you about 15 dB. No?
No, because it was level independent.
Yes? Okay.
I was varying the noise level as well.
Okay.
But,
Bon.
yeah, maybe.
Maybe. But there is on the inside the NIM, we have a RF booster. So we have this booster, but we have the zero tuner, demodulator, and the interface with the PC is just a USB converter. The parallel signal, the transpose stream that we get in parallel mode, we'll put it in USB mode, in serial mode via the USB interface. If we look inside a zero tuner chip, there is only one chip that do all the job. There is a PLL. This PLL is dependent of quartz, and the step of the PLL is for the 1600 card and for mini tuner with a sharp, is the frequency of the quartz divided by 32. So the step is for the Technotrain card 843 kilohertz. So when you ask a frequency, the card can only be set on a frequency that is a multiple of this value. So it can be set to a frequency at 400 kilohertz of the frequency you have asked. This is the first error. The second error will be that you are not sure of the frequency you are receiving. That can be also, that can have an offset. We will see how the derotator will work to eliminate that kind of problem. We have inside, so we have a parallel. The arrays come in. We extract just I and Q. We have some preamplifier with an AGC control. And we have a low-pass filter. This low-pass filter, one for I, one for Q, can be set only between 5 and 36 megahertz. So the lower value we can have is 5 megahertz by signal. That gives 10 megahertz for the bandwidth for the signal we are receiving. We cannot go lower. So for low symbol rate, when we want to receive very low symbol rate, it could be a good add-on to be able to add a filter between the zero tuner and the demodulator. And we have also another amplifier, the baseband gain, at the end of the zero tuner. All inside the card. The zero tuner give me I and Q. I have two ADC, digital converter, that runs at about 120 or 155. 120 if you have 25 quartz, megahertz quartz. 120 megahertz when you have a 16 megahertz quartz. This is the standard frequency. For low SR, I have changed the frequency to 60 megahertz or 54 megahertz. This is the first change I have made. So, IQ are digitized. So, if we look at all what is done inside the chip is digital work only. The only part that is analog is we have at this step, after eliminating DC offset, or I don't see where is it. It's better. Okay, we eliminate the DC offset, correction of amplitude imbalance, and here we have integration of the signal, conversion in analog, and the AGC signal go to the tuner. This is only the analog part. So all what will be done inside the chip is all be done by software. By software inside the chip, programmed software. We have the derotator. Derotator, this is a parallel loop that tries to find the carrier frequency, the exact frequency. As I said, perhaps you are 200 kilohertz behind the real frequency. So by software, the derotator will search how to lock in all the signal that has been digitized, how to lock on it. And you have also a second parallel, range corrector. This is another parallel that tries to find and to lock on the sample rate. Also, the sample rate is not always the real frequency you think. It can be a little upper or lower. We have also a second AGC, numerical digital AGC, an equalizer for inter-symbol interferences and echoes. And all this part has the job to lock on the carrier and to lock on the symbol rate. And we will see that it is what we need to work. The remaining phase is just to detect the puncture rate with the fake, to decode with the Viterbi decoder. At these times, we no more have I and Q digital data. We have only one stream of bit. And this is, I have simplified here because this last remaining work is written in serial mode, but there are some interlinked work inside. So we need to find some packets of data with what is called a synchro byte. There is a specific byte. It's 47 in hexadecimal. We need to deinterleave them. There will be a Reed-Solomon decoder that will change the 240 byte packet for a packet to 188 byte by packet. And you will have, after the descrambler, you will have the transport stream. Anyway, we have two steps. The locking process the decoding process. When we lower the symbol rate, the decoding process is the same. He has no more work to do. The difficulty will be to lock. When we lower, the rotator and one range corrector will have difficulties to find. Just it's what I have said. So, when we have to program the demodulator chip, we have many registers Okay. We have many registers to set up. There are about 50 different values to give only to set the derotator, the different kind. We can compute all the timing as with the same result as it will be a real PLL. We have a PLL, we have different constants we can change in the PLL, and we must play with them. So the first solution was found after 3 months. It was the version of Tutioune, the 0.6H. Tutioune, for people that don't know this software, allow you to choose the symbol rate, the frequency. You can also set up the FEC if you want, but if you write absolutely no FEC, it will find itself the FEC. When you ask for low symbol rate, that will change many things inside, not only the frequency of the master clock, I have said, not 120 megahertz, but 60 megahertz. But it will change many things for the work of the derotator. This part is for your web monitor. I have one slide about that. When you use this software, if you press this button, you send in real time all your data on the web. So that allow to someone to look on the web exactly how he is received on your station in real time. So if you change your antenna, you can see the RF level or the constellation, because you will find this data on the web. This is just for that. Here you can ask to detect automatically the PID. The PID is number that is used in the transport stream to know that all packets with this number are packets for the video, all the packets with this number are packets for the audio. So we can send them to the video decoder and the audio decoder. So if you don't know them, if you know them, you can write them. If you don't know them, that they will be found automatically. And you have also some button to record the transport stream, to send it via UDP in your local network. And you can save also on your hard disk all the data during 1 hour, 2 hours, 1 day, 2 days. We use this very systematically for the ham TV reception. And you have here all the measuring. What will be very important when you want to receive, you look at these two LEDs, the carrier lock and symbol rate lock. And when you will have difficulties, it will be with the carrier lock. It's when you are playing DX, the shape of the signal is transformed. It's not exactly very symmetric. So it is easier for the demodulator, for the PLL of the symbol rate, of the timing lock on the symbol rate. It is easier for it to find the rate of the phase modulation, but because it is not more disturbed, but it is more difficult to find the center of the frequency, because your shape is not a very beautiful shape, as we have seen at the output of the DigiFin. So we can measure the RF level, the MER, that is the best value for us for a report. It is the signal to noise, the digital signal to noise result. And we have the constellation. We have also the work made by the VTRB decoder. You can know the number of errors you have. It will go more and up when we have difficulties, and at one time it cannot correct all the packets, and you will see here some number of packets that have not been decoded. Yes. Now, since last week, Minitune can do exactly the same job. With something I like better, you can take photo directly. We have, and I have added this thing just to know by hitting a spec you can have what?
No. Carry on.
Okay. So Minitune now can do all the job. The only thing I have not finished in Minitune is the ISS option. It's just specific for receiving ham TV. There is a bug in the transport stream that is sent. So I have added in Tutioune, I have a specific procedure, no? Yes, procedure. Excuse me for my English. I have yes. Okay, you will ask all your questions in French. Okay? No question. Okay. I have been obliged to put a specific procedure to add the DVB tables, because there is no DVB tables in the transport stream sent by the ISS. in a transport stream, you have the DVB tables. DVB tables is just some packets where are written that the video is on PID 1000, audio is on PID. And when you don't have any tables, your set-top box cannot receive it. It cannot find where is the video, where is the audio. So in real time, with Tutioune 1600, I add the DVB table in the transport stream in real time when I receive it. So this is the only thing that doesn't work today in 1 month or next week.
When you get time.
Yes.
Yeah.
It's off air at the moment.
Yeah.
You've got a week.
So what I've just explained, that. Okay. So when you want to receive, you have just to check if all your LED are green. And when all your LED are green, you are receiving the transport stream. Just to show you, I have made a test using always the same level, because in their mind, many OM said me, oh, if we know the RF level, we know the noise, the carrier noise,
Signal to noise?
signal to noise, or carrier to noise. So we can know if we can receive or not. So this experiment shows that it is not the truth. I have always the same RF level, but at the end I can't receive. What is changing? The MER. Because on my modulator, as was adding more and more fast noise. That's all. So here I can receive. Okay, I receive. The constellation are bigger and bigger clouds. The Viterbi corrector is working. Here, the Viterbi corrector is working. Viterbi corrector is working, and Reed-Solomon corrector is working. And all is green. Okay, I continue to receive. But now, the Viterbi corrector and Reed-Solomon cannot correct all the errors, and the transport stream is red. So I cannot receive now. Tutioune, there is a little button to go in expert mode. Expert mode is bowing. We have many things we can set, but what will be very important for low symbol rate is this new panel. This new panel was not here with the precedent version. We will see. This is the frequency I asked. This is the frequency that is... Oh, better and better. This is the frequency that is the multiple of the step. And this is the deviation of the carrier, of the derotator, to find the carrier. The derotator, this PLL, work and find that the deviation was 394. So the real frequency is 1255 or 50 kilohertz. For the symbol rate, I ask 250, 250 kilo symbol. The symbol rate that will be set is not exactly this value. So here also the second PLL will find that there is an offset of 355. If you add them, we are about 250 kilo symbol. This panel will be important and we will see it. Minitune is the same. You have something now with Minitune in expert mode. It's very similar. I have changed just some place for some button. Yes. Okay. Now, when we set the frequency in a traditional receiver, we just set the frequency and we don't set the offset of the derotator. The starting offset of the derotators is 0. To get more quickly the good frequency, now when I see that it is not exactly the frequency I have asked, there is 344 344 kilohertz lower we are. I say immediately to the derotator, start at 344 kilohertz. It's not, you have not to start to 0 to go, because the derotator is searching in zigzag. There is, he start where he starts at 0, or if I forced it to start at 344, he will start at 344, and after he will search in zigzag up to 1 or 2 megahertz up, and after 1 or 2 megahertz down the frequency. So yeah, we are locked, so he has found, but he started at 344. We have now this panel. This is, I have called it the scan strategy. When you ask for frequency and symbol rate, we write in the registers that we want this frequency and this symbol rate, and we ask to the demodulator, work, search. So the double PLL start to search. This is this button. When you do that, you have chosen the frequency, the symbol rate. OK, when you click OK, you are searching. But if you want, at any time, you can click on one search and you start again from the beginning. Because if you want that he is searching very far, and you know it's not at this place, you can ask, you can click many times on one search to restart at the starting frequency you want. It is when you are in no-loop mode. When you are in loop-wide mode, it will search. Alors, in loop mode, so loop mode, you have a timer. Every 8 seconds, it will click itself on the search button. And you can change, there are two modes, wide search and narrow search. This is the second thing I have changed. I try to tell to the derotator not to search very far. We are ham radio. When we say one frequency, we are not 1 megahertz far from the frequency. So we can ask him, you can change this value to tell him to search very few kilohertz, tens of kilohertz, dozens of kilohertz, up and down. Or 100 kilohertz up, 100 kilohertz up, down. The narrow range is just because this value is set lower than this. It's because you can work in chain mode. When you work in chain mode, when you lock for the first time, this LED comes green, and automatically it will go in narrow mode. It will use this range. That means this is used for QSB. When you have found for the first time a station, but it is very low level.
Marginal.
And
Marginal? No,
marginal? Perhaps, no.
It sounds French to me.
No. No, it's a very little signal in the noise. And with the QSB, sometimes you lock on it, sometimes you lose it, you lock on it. So, when you have locked the first time on a signal, it's not, you have not to search 1 megahertz or 100 kilohertz away if it comes back. If it comes back, it's on the same frequency. So, when we have locked the first time, we will go in narrow mode to stay very near the frequency where we have lost the signal. Some people ask me, when we can't lock, what can we do?
It's so annoying to be sitting there 150 kilometres away and it's
Yes.
almost...
One LED is green,
Yes.
not the second.
The symbol rate light is green, but there's nobody there.
Okay. I have also changed in the standard demodulator, the symbol rate scan is 25% of the symbol rate you ask. When you are in low symbol rate, now I have asked only 2%. So if you ask 200 kilosymbol, it will search between 204 kilosymbol and 196 kilosymbol. Just to be able to lock quickly. So you have all this kind of parameters you can change. There are different type of algorithm, but I have never found that There is some that is better than other. And this is also important. Yes. This is specific to narrowband. With narrowband, I discovered that when I was using a professional modulator, when I was using DTX1, when I was using the Raspberry Pi in ugly mode, when I was using, I had a parameter that can be very important. And this is the parallel corrector. And I think it's supposed, I suppose, that it is in relation with the kind of the way, the shape. The shape with big shoulder, little shoulder, to be able to find the central frequency. So, with my professional card, the parallel corrector is 0. In ugly mode with the Raspberry, I think I must put 3 or 4 for the correction. So that is also something that can be important.
We found that would give some sort of hysteresis. Once you'd locked on a signal, it would hold it longer. But then when the signal came back, you had to put it back onto auto. It seemed to act almost to hold on to the signal longer if you had that set to a lower value.
So, I have said you can send, using the web button, you can send in real time all what you are receiving, all the measures. You can see on the tune monitor, you can see all the stations that are using Tutioune or Minitune, and the station that have pressed one time the web button. When you press the web button the first time you press it, that creates automatically your icon. When the icon is red, the station is off. When the icon is green, the station is listening. And when the icon is jumping, the station is receiving. This is what, if you click on the icon, you will see that. You know what kind of car. Now you will see Mini Tuner, or Technotrain 1600, or Technotrain 3200. And you will see the RF level, the constellation, MUR, the frequency. So when you have some a green icon, you click on it, and you know that this is a station that is open, that is listening. And if you look at this, you will see on which frequency it is listening, at which symbol rate. And you can have the last 2 hours of data, and you will have the picture, 1 picture by second, when the station will receive it. Donc, now the mini tuner can work like the Tutioune. Mini tune do the same job. Now bandwidth DATV is possible. What I can say for the end is that this summer with Foxtrot 9 Zulu Golf, We have made tests during 10 days, every day in July. I was on my secondary station at the south of La Rochelle. He was at his home à la Manche, in the Manche, near Saint-Lô. 350 kilometers. Every day we succeed, a good contact. I have all the video, I record the video. We succeed every day using the 70 centimeters band, using about 200 watts. And the standard have just 21 element big. In August, we tried again. All the tests were made at 250 kilosamples. This is the frequency we prefer in France. And because it was for me the best mix to have the best video quality and the lower bandwidth as we can. And in August we tried again during 5 days, and most of time we will not be able to receive themselves at 250 kilosamples, or only 5 or 10 seconds, and we go down to 125 kilosamples, and it works very well. I can say that it was not possible to try at 1 megasample. You can be sure we receive nothing, and with analog television we just see English fog with some shadow.
Okay.
Thank you.
Thank you. So a lot to take in there. My question to Jean-Pierre was, you know, what can we do to optimise the performance? And I sense that we've still got a lot of work to understand what are the correct settings when it's in real life on air signals. Is that right, do you think?
Yes. For me, the first thing to do is to change. Oh. I lost my microphone, sorry.
Actually, didn't know.
I don't know why it is jumping.
It's your arms. Derotators.
The first thing for me is to lower the latency. We have talked about, there is a latency with the Raspberry Pi encoding system, and there is also a latency when you are receiving, because we have big buffers. If I send, when I receive, if you click on the UDP button, the transport stream packets are sent immediately as soon as they are received. There is absolutely no buffer. But when VLC receives them, he has a big buffer. So perhaps if someone has some time, he could search if we can set up VLC to lower the buffer. When Tutioune or Minitune receive itself, the system I'm using today is also a big buffer. So it gives me at, if you are playing at very high cymbal rate, you don't see anything, it's not a problem. But at low cymbal rate, at 250 kilo cymbal, this buffer add 2 seconds of latency. So for me, it's one thing that I must work.
Okay, any questions? There was a lot there.
In French?
Yeah, en français.
En français. Your sweep widths had numbers against them. Do they mean anything in terms of how many hundreds of kilohertz?
Where?
Yeah, the sliders have numbers against them, where you say pre-lock and post-lock.
Yes. No, it's just it corresponds to the parameter I write in the register.
Okay.
That's all.
So it's relative.
Yeah. At what symbol rate should you tick the low symbol rate box?
Below what symbol rate is low symbol rate?
What is the changeover symbol rate when you should tick the low symbol rate
1
box?
megasymbol or 500 kilosymbol?
When you can, stay in low symbol rate mode.
Right.
That's all. Alors, low symbol rate mode is from 120, about, depends of the quartz, and 6,000
Right. Okay.
megasymbol. So, for us, for ham radio, I think it's better to stay always in low symbol rate mode.
Okay, thank you.
Anybody else? Terry?
In the new Minitune software, I noticed that the auto PID switches itself off very quickly. What's the function behind that?
Here?
Yeah,
Yes.
you put it on and a few seconds later it goes
Yes.
off. Yeah.
Yes.
This is new.
Yes, I'm proud.
Tell us more, please.
Yes, thank you.
Why?
Because I don't know, something will be changed perhaps. When you click on this button, you will see, I have the picture of you will see a page that gives you information about your mini tuner, if all the drivers are well installed and so on. And you will have at right the result of the auto PID search system. And you have the number of search he has made. And very often, one search he finds. Before the way to search the PIDs was not the same. Now, when I receive the stream, I don't know, I have not tested at very high symbol rate yet. I don't know if it works very well for that. But now when I receive the packet, at the first time I receive them, immediately I will check inside all packet if I find a packet with data, with tables. I discard the packet if there is video. And I check all packets with data until I have found the video, audio PID, and the codec. And it is only when I have found the codec that I switch up if you have
Lock it.
I unlock the auto PID button because we don't need to slow the computer or the software by searching in all the tables.
So it just means it's done it quickly. That's why he's proud of it. Terry, can you, behind you?
I find that it doesn't want to find the PIDs in auto, but as soon as I type in the figures in the boxes below, within a few seconds it does find them and locks up. Is it necessary to clear the figures that are in those boxes before going to auto?
No.
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 It doesn't
With the
want-
1600, I know that auto PID doesn't work always.
No, it's a 3200.
It's
a 3200.
it's on Tutioune or Minitune?
A Tutioune.
Tutioune, yes. But on Tutioune, I can say that sometimes auto PID don't find the PID.
Okay.
It don't find the PID at low symbol rate because in Tutioune, the procedure that search the PID takes a window in the time to search. If the tables don't come between inside this window of time, it don't find the PID. So now I don't work like that. I don't take a window of time to say during 1 second I search the tables. Now I am searching the tables until I have all the data.
It's easier just to type in the figures.
So
If you know it,
I think now that Minitune will help me to improve Tutioune because I'm working on Minitune.
Good. Any more?
Is there anything on the net?
I've got one in the meantime. I don't know if we're monitoring the net. I think Dave is.
All right.
Just a comment. It's not a criticism, but the box that says tick for no Doppler, the logic
Yes,
in the brain is wrong.
Yes, yes.
To tick for no Doppler, it really should be tick for
Yes, I know.
Doppler. Yeah.
Yes.
If
Yes.
you could change that really confused Graham. He thought it was.
Yes, yes, but I started like that
I
and
know.
after.
Yeah.
But I say if I change it, people that now know that. So I let it.
I was also wondering.
Okay, I agree. It's strange.
Yeah. I was wondering if some of the parameters, such as the ISS and some of the low symbol rate stuff, if you could put that in the INI file, so you don't always
Yes.
have to go and.
Yes,
And
yes,
yet-
and this is I will. It will be invisible in next version. You don't see it anymore.
Yeah.
We need it only for the ISS.
Yes. So therefore you could, when you tick ISS, you could put
Yes,
Doppler in.
yes, exactly.
The other one is.
But I have to.
I know.
There are many priorities. Each day I receive email. Oh, the priority is this. Oh, the priority. Oh, can you? Oh, could you?
Have you got a PayPal account?
That works. that one there.
Yes,
Should we always tick auto for gain?
you could. Yes.
No, that wasn't the question. I know I can. Should we tick auto? Or what should we set the gain to? Is it right that it is 0?
I can say today the auto gain is to set up the baseband gain automatically. I have spent many times with the Technotrain cards to set up and to find the good value.
Yeah.
As now today we are changing
To Minitune.
the NIM,
Yeah.
and the NIM has not always the same chip, the same RF booster, and so on. I'm not
So
sure.
play with it.
Yes, I'm not sure that the auto value
He's right.
I have programmed is always the best.
Okay,
It takes time to.
good. Well, I think we'll leave it there. Jean-Pierre is here for the weekend. I think it's fantastic to have him here. Brilliant job he's done. Really revolutionised what we've done.
Thank you.
Very good. So now